Hello everyone, I'm Kiyu Tanaka from the University of Tokyo, and today I will talk about detection thresholds for replay and real-time discrepancies in VR hand redirection. Video self-modeling is a technique where learners observe their own ideal performance. Typically, it involves recording the learner's behavior and then editing it so that the performance appears improved. This approach is expected to enhance learners' self-efficacy in motor learning. Hand redirection is a method that shifts the position of the user's physical hand and virtual hand without the user noticing. One major variation of this technique is known as gain warp, which applies a gain, a scale factor, to the user's reaching distance, thereby scaling the virtual reaching distance. Recent studies have reported that hand redirection can help increase motivation during upper limb rehabilitation. Within hand redirection, the detection threshold is particularly important. During reaching tasks, it is possible to scale the movement from about 0.88 to 1.07 times without the user perceiving the difference. In this study, we integrate the concept of video self-modeling, where people observe their own movements after a motor task, with hand redirection. As a first step, we measured the detection threshold in two replayed scenarios. In Experiment 1, no scaling was applied during the motor task, but the replay shown afterward was scaled. In Experiment 2, scaling was applied both during the motor task and during the replay. Experiment 1 employed a within-subjects design with one factor and two levels. 18 participants were tested under two conditions: no replay and replay. We used the method of constant stimuli with 9 gain levels, each presented in random order and repeated 10 times. The two conditions were administered in separate blocks. In the no replay condition, participants did not see any replay. We measured the conventional detection threshold for gain warp by asking participants, after each reaching movement, whether the virtual movement was greater or smaller than their physical movement. In the replay condition, after participants performed each reaching movement, they viewed a replay of that movement which was scaled. Following the replay, they answered whether the replayed movement was greater or smaller than the physical movement. We calculated detection thresholds for each participant. The figure on the slide illustrates one participant's data. The horizontal axis represents the gain, while the vertical axis indicates the probability that the participant judged the virtual movement to be greater than the physical movement. We fitted these data to a psychometric function to derive the lower and upper detection thresholds, as well as the PSE, point of subjective equality, and JND, just noticeable difference. These figures plot the results for all participants. Statistical tests showed that the lower and upper detection thresholds, as well as the PSE, were significantly higher in the replay condition than in the no replay condition. There was no significant difference in JND between the two conditions. Next, we interviewed participants to understand how they differentiated the manipulations. Under the no replay condition, participants reported paying attention to the angle of their elbow during reaching or judging the virtual hand speed relative to the physical hand. Under the replay condition, they focused on recalling the visual endpoint of their reach and comparing it with the endpoint shown in the replay, as well as assessing the replayed virtual hand speed. In the replay condition, the PSE was 1.13, which means that when the virtual hand moved about 13% more during the replay, participants perceived it as matching their physical movement. A possible reason is that without proprioceptive information, people may underestimate the distance traveled. Meanwhile, regarding the JND, there was no significant difference between the replay and no RP conditions. This suggests that participants' ability to detect deviations from the PSE was almost the same across conditions. Even though participants used different strategies to identify manipulations in the replay versus no replay conditions, the JND values were similar. Next, let me move on to Experiment 2. This experiment also used a within-subjects design with one factor and two levels. We recruited 20 participants, who experienced both no replay and replay conditions. We employed the method of constant stimuli with 9 gain levels, each presented in random order and repeated 10 times. The experiment was blocked into sessions without replay and with replay. In the replay block, we included an additional dummy condition. In the replay condition of Experiment 2, the reaching movement was scaled in real time, and the replay showed this scaled virtual movement. By contrast, in the dummy condition, the reaching movement was also scaled in real time, but the replay presented the participant's original physical movement. After viewing the replay, participants answered whether the replayed movement was greater or smaller than their physical movement. Here is the figure plotting the detection thresholds for each participant. Statistical analysis showed no significant difference in the lower detection threshold, but the upper detection threshold, PSE, and J&D were all significantly higher under the replay condition. We also interviewed participants to understand how they distinguished the manipulations. In the no RP condition, as in Experiment 1, participants tended to focus on the angle of their elbow during reaching, or on the speed of the virtual hand compared to the physical hand. Under the replay condition, participants could no longer rely on the visual endpoint during reaching. Instead, they depended on proprioception, imagining the movement distance based on their bodily sensations, and then comparing that with the endpoint shown in the replay, or judging by the virtual hand speed during the replay. From the PSE results, we found that the movement distance in the replay condition may be underestimated. Moreover, the J&D was higher in the replay condition than in the no replay condition, indicating that scaling during reaching may diminish participants' ability to discriminate deviations from the PSE. During reaching in the replay condition, participants could not rely on visual cues to estimate movement distance in real time. Instead, they had to depend on proprioceptive cues, which may have led to reduced estimation accuracy. And, because we included a dummy condition, the total number of trials increased, which may have caused participants to experience fatigue. So, to summarize our work, in Experiment 1, no scaling was applied during the reaching task, but the replay itself was scaled. In Experiment 2, we scaled the movement both during the task and during the replay. In both experiments, the PSE turned out to be higher in the replay condition than in the no replay condition. This finding suggests that people tend to underestimate distance during the replay, regardless of whether or not the movement was scaled in real time. Meanwhile, looking at the J&D, in Experiment 1, there was no significant difference between conditions, but in Experiment 2, the J&D was higher in the replay condition. We believe this result arises from the fact that, in Experiment 1, participants could rely on visual information when estimating their movement during reaching, whereas in Experiment 2 they couldn't, so they had to rely more on proprioceptive cues, which affected their discrimination accuracy. That wraps up my presentation. Thank you very much for your attention.